Hello, my name is Taha. This is my personal expenses tracker application developed in Java for OOP2 module. The application allows the user to manage income and expenses, organize them by category, generate reports, export data, and apply user settings such as language and currency. The system uses a layered architecture with UI, service, DIO, and model layer, and it stores data persistently in MySQL database locally. So the application uses MySQL for persistent storage. So I have already started the database locally, and the application connects to it through JDBS connector. So when I run the app, you can see the application. When the application starts, it loads the saved settings and opens the main interface, which are organized into tabs for transactions, categories, reports, and settings. In the categories section, the user can create and manage categories for both income and expense transactions. So for example, if I add here the name of the for the category, so let's say rent, and let's set it to income, and then okay, I can add it, I can see it here, or delete it as well, then it will be gone. And I will add an expense MCT or something like that, for example, and then add it, and I can see it here. And when we go in the transactions section, the user can record financial activity. Each transaction contains a title, amount, type, category, date, and optional notes. Here we can see it. So you can see the title. If we say, let's say 200 income, so it depends on the type. The category, it depends on the type, so it pulls it from the category table and display it here as a drop down menu, and the notes are fully paid, and then we can see it's added now. And here, as we can see, we can export the CSV file. So if I click export and then OK, and then come back to the project manager, refresh, you can see the export. If I go to the reports, and we can see here, I also can export the file. We can see the total expenses, the total income, the balance, and the category summarized, and monthly summarized as well. And if I go to the settings and I change something, for example, let's change the language to French, and then it's in French now. Or even if I can change the currency from euro to dollars or to pound. Let's change it to English again. And because I exported the file, so I can just want to refresh it and show the text file. Before looking at the implementation, I will briefly show the overall project structure. DAO handles the database connection and the access using the DAO pattern. The service here, this contains the business logic and core application processing. And the model, this defines the data structure used across the system. UI is responsible for the user interface and presentation layer. Application also uses properties files for externalized text, allowing easier maintenance and potential localization support. For example, multiple languages file can be supported. Here I have the demo snippets. I also included a separate demo snippets folder to showcase newer Java features independently from the main system. This includes examples such as the compact main method and other modern Java features to demonstrate awareness of recent language update. I will now highlight some of the advanced Java features used in the project. Here we can see the use of Java streams and collectors in the reporting logic. Transactions are filtered to include only expenses, then grouped by category using grouping by. After that, mapping and reduction are used to calculate totals, and the results are stored. I used stream here because they provide a more concise and readable way to process collections compared to the traditional loops. Concurrency is demonstrated here using ExecutorService along with Scalable and Future. This allows multiple report calculations to run in parallel instead of sequentially. I used this approach to improve the performance and to demonstrate multi-threading concepts in Java. Java records are used here to represent immutable data models such as dashboard, summarize, and report results. They reduce boilerplate code by automatically generating constructors, getters, and other methods, making the code more concise and easier to maintain. Sealed classes are used here to define a controlled hierarchy for export requests. The export request interface explicitly permits only specific implementation, which improves type safety and prevents unintended extensions. This ensures that only valid export types, such as transaction and summary export, can be used within the system. Overall, this project provides a complete personal expense tracking solution while also demonstrating both fundamental and advanced OOP Java concepts in a practical application. Thank you.